Well, hello, class. In a pretty crazy turn of events, turns out I'm going to have the baby this weekend. So the beeping you hear in the background is, I don't know, the hospital sounds. So if this isn't dedication, making a video while sitting in a hospital bed, gonna give birth within the next 24 hours, I don't know what is.
I'm here too.
And Mr. Scott is here too, so to witness the fun of math. The page I'm on right now in your binder is page 4. This is the example we did not get to yesterday, and I'm going to talk a little bit about finding the inverse of this function, starting with finding the domain and range. We talked about yesterday that a parabola is not one-to-one, so because of that I cannot find the inverse of that parabola unless I cut the parabola in half. So what this is right here, this is called a restriction. And if we restrict the domain, then I can find the inverse. So x is less than 0, if you think of that green parabola on the origin. X is less than 0 means I'm literally cutting out this half of the parabola. So I only have this half of the parabola, and now that half of the parabola is one-to-one, and therefore I can take the inverse. So for part A, it asks me to find the domain and range of the function. Well, hold on. Usually the domain for x squared is negative to positive infinity, but we've restricted that. So when you're given a restriction, that becomes your domain. So the domain is x is less than or equal to 0. Let's write that in interval notation. That's negative infinity to 0. There's the domain of my function. And the range, if you guys look at the picture, x squared goes from 0 to infinity. So there's my domain and range for the original function. Now, for my inverse function, the domain and the range are going to swap. Because if I have an original function, all of the x values, which is your domain, and all of your y values will swap for the inverse of that function. So that is part D. Part D, we're going to skip right to it. The domain of my inverse function, which we're about to find, is what the range originally was, which is 0 to infinity. And the range is going to be what the original domain was. So that's negative infinity to 0. Okay, so we have now done parts A and D. Now it says determine if f of x is a one-to-one function. Well, it wasn't, but now with the restriction, it is. Okay. Yes, because of the restriction. So now we've done B. All that's left to do is to find the inverse itself. So the process that we talked about yesterday is that we write the original function, which is y, part C, y equals x squared. I just replaced the f of x with a y. Next, we swap out my x and my y. So x equals y squared. And now I'm going to get y by itself. Now, when I square root both sides, technically I get a plus or minus, so we'll talk about that. We get y equals plus or minus the square root of x. Okay. Here's the problem with my answer. If I graph positive square root of x, you guys know what that looks like. Root x is this function right here. But if I graph negative square root of x, it goes upside down, and my answer is no longer a function. It doesn't pass the vertical line test. So it cannot be plus or minus. It's got to be one or the other. So the question is, which one is it? Well, what we're going to do is look back at my inverse domain and range, because this is the domain and range of my answer. Okay, so the domain needs to be from 0 to infinity. Well, both of these are 0 to infinity, so right now that doesn't help me. What about the range? the range needs to be from negative infinity to 0. Well, the purple one is 0 going up to infinity. It's the blue one that's negative infinity up to 0. So it's actually the negative root x. That's my final answer. So my final answer, we're going to use the correct notation. F inverse of x is negative root x. So now I've done all of the parts A, B, C, and D. I'm going to stop the video here, and I'm going to do some more examples from the next day of notes.
Do it!
But I'm going to chunk it so that you don't have like a 30-minute video coming your way. Guys, I know that this baby's coming earlier than we all anticipated, but Mrs. Jensen's ready to go for Monday, and no worries. I'll be back earlier than expected in May. So we'll finish the year together, and we'll be together longer then. And I will send you guys updates when this baby gets here.